As he said, well, my presentation is on this shrimp and on its parasite and the impact that this one has on the reproductive output and on its fishery. And I've been doing my thesis with GMIT, which is based in Galway in Ireland. So crustaceans are a very important components of landings worldwide, and they composed 8% of total catches around in 2016. And between them, the shrimp is the most exploited group of species. And in Ireland, the target of the shrimp fishery is Palaemon serratus. This fishery started in the 1970s, and it is now, the species now one of the most expensive shellfish fished in Ireland, just after the crayfish. It is an important resource as it represents revenue for fishermen during winter when other fisheries are closed, and it's part of an important export market. And in the figure, we can see the typical shrimp trap that is used in this fishery, which has generally a mesh size of 7.5 millimeters. So the lifespan of Palaemon serratus is of around 2 years. It begins the first year with hatching in April, while in June, the juvenile settles in shallow water. Between August and September, there is a period of fastest growth of the species. In October of their first year, the shrimp recruits in the fishery at a length of 55 millimeters, while in the winter months, both age groups, they migrate offshore to deeper waters. The second age group is the one that carries out the reproductive effort, with the second year group being, or a small cohort of the second year group being already buried in May, while the biggest reproductive effort is between October and March. There is a closed season that serves to protect the species between May and July, during which all commercial fishing is not allowed. While between August and December, there is the main exploitation period for the species, the August and December of the second year. And during their third summer, most of the shrimp die. What has been observed in the last 20 years, it has been very variable size of the landings. And this has generally been explained with variable recruitment of the species. So as this shrimp has such a short lifespan, the population size will vary a lot depending on the recruitment of the shrimp of the previous year. And this has been sparking worries as the shrimp's population size is very unpredictable, and right now we have no means to know for sure what will be the landings for that year. And it has been sparking worries because if there is high fishing mortality due to high fishing effort, and these are coupled with these years happens in the same time when there is low population size, the population of Palaemon serratus could be severely affected. It is also cause of concern that there are not many management measures put in place. One is the closed season that we already saw, doesn't really protect the reproductive females. And also the other management measure is the use of the voluntary use of the grader by the fishermen, which is used mainly at the beginning of the season to discard the shrimp that still have to grow fully to give the maximum yield. But as I said, it's a voluntary use and it's not that widespread. Another threat to the shrimp's population size is Bopyrus squillarum, which is a parasitic isopod that settles in the gill chamber of the shrimp. The female of this parasite attaches to the shrimp and feeds on its hemolymph, and the male settles on the tail of the female. So it's a sexually dimorphic species, and the male that we can see in the bottom left figure, at the bottom of the figure, serves only for reproduction. This parasite is cause of concern as it is a parasitic castrator. So while the female is attached to the shrimp cannot produce eggs or sperm. And this parasite also creates a Latreille bulge that may cause an impediment which can impede the shrimp from escaping the trap, for example, or can be blocked in the grader, although it should be expelled by the grader. This parasite has been also observed to have a very high prevalence in some sites in Ireland, around 30%. but no study yet focused on its impact on reproduction and on the fishery. This is what I tried to do. I tried to investigate the impact of the parasite on recruitment by estimating the amount of missing eggs that could have been produced by females that were instead parasites or instead infected. Then I also tried to investigate the possibility of the parasite leading to greater retainment of smaller shrimp by the creation of these bulge that can block the shrimp from escaping the trap or escaping the crater. Also, I tried to estimate the potential economic impact of the parasite given on the fishery. To do so, I studied samples from 6 sites across the western shores of Ireland. As a little summary, the 3 northmost sites were the only ones with buried females, while Roundstone, Carrigaholt, Ballylongford, and Finnet were the ones with the highest prevalence. So, to estimate the amount of what they called missing eggs, the eggs that could have been produced, I first modeled the functional maturity of the females in December, and also the fecundity. The functional maturity is the probability to be buried, the probability to be carrying eggs. Buried means carrying eggs, maybe I didn't say that before. The probability to be buried at a certain length, as we can see in the graph on the left. While the fecundity is the possible number of eggs that could be produced at a certain length by a buried female. Afterwards, I calculated the probability to be buried of each infected female and a possible amount of eggs that could be produced by these females if they were not infected and if they were in fact buried. And then I imagined 2 scenarios. One scenario that summed all the eggs of all the infected females that had a probability to be buried more than 20%, which added 10 buried females to the pool of, in real life, 40 buried females. And the scenario 2 with the same criteria, but the threshold was now 30%. And this added 4 buried females to the pool of 40 buried females. I found that for scenario 1, the site with the highest amount of missing eggs was Roundstone, with around 17,000 missing eggs, while Ballylongford and Finnet were the sites with the highest increment of eggs if the missing eggs are summed to the number of real eggs. But the highest increment, because Ballylongford and Finnet started with 0 eggs to begin with, there were no buried females. Well, for scenario 2, Roundstone was still the site with the highest amount of missing eggs, while Ballylongford was the site with the highest increment. Galway Bay caught my eye, as there were quite a few buried females that had a very low probability to be buried, and some of them had a probability to be buried around 3%. Afterwards, to investigate the possibility of the parasite leading to greater retainment of smaller shrimp, I compared the prevalence between 2 groups. Well, first I will explain a little bit the diagram in the bottom, the illustration. So the square is the mesh size of the trap that is used to fish the shrimp, and the oval it's the shrimp's carapace section. And the rightmost illustration is the shrimp with the parasitic bulge. And so I compared the prevalence between these 2 groups. One group was all the shrimp that had a normal carapace width smaller than 7.5 millimeters, while the other group was all the shrimp that had a normal carapace width more than 7.5 millimeters. So all the shrimp that should be retained when they don't have the parasite. But no significant difference in prevalence. I found no significant difference in prevalence between these 2 groups. And I also compared the carapace width of an infected shrimp with the carapace width of infected shrimp, and I found out that the carapace width of infected shrimp was the same size as the carapace width of uninfected shrimp that were 4 millimeters in length longer of carapace length, so quite a sizable difference. Finally, I calculated the cost of the misgraded shrimp. Well, to estimate the potential economic impact of the parasite, I calculated first the cost of the misgraded shrimp, following this reasoning. So as the shrimp is priced upon size, and sometimes the shrimp are divided by size with by the carapace width measurement, the shrimp that have the parasitic bulge will have a higher carapace width, and they will be priced more even if they should be priced less. So I calculated this difference in price. And also I calculated the the price of what they call the price of the parasite, the cost due to the weight of the parasite, to the added weight of the parasite. And then I did a thought experiment. I tried to calculate, well, I did. I calculated the cost of the parasite in 2018's landings, which consisted of 165 tons of Palaemon serratus and probably Bopyrus squillarum being fished from the sea. And this generated a revenue of around 3 million euros. I calculated that because of misgrading, 132,000 euros could be accounted for by the misgraded shrimp. And this was the contribution price given by the misgraded shrimp, which accounted for, which could have accounted for 4% of the total price, while the parasite weight could have contributed to up to 20,000 euros, so 1% of the original price. I did this calculation assuming that the prevalence that I found for the sites that I surveyed were representative for all the catches of all Ireland. In conclusion, what I found is that one of the biggest impacts is given on recruitment, especially for sites where shrimp are of big size, like in Ramston, but there is also high prevalence, so there is a higher amount of eggs lost, quote unquote. Also, I found that where there are in sites where there is high prevalence and small size, for example, in Carrigahoe, Longford, and Pennant, there were no buried females, and this is maybe due to the fact that the few buried females that could be buried were not buried because of the parasite. But also it could be also because the energetic burden given by the parasite that keeps the shrimp small, or also the parasite could affect the survivability of all the shrimp, and so all the older shrimp that could produce eggs, they die instead. But I also found some evidence that other conditions are probably influencing the egg production in Palaemon serratus. I found some evidence, as I said, in Galway Bay, where a few females that had a very low probability to be buried were instead buried. So there were probably very favorable conditions for egg production for Palaemon serratus locally. About favoring retainment, I found no evidence that the bulge favors retainment in the pot. In the trap, sorry. But I will conclude that this needs more investigation because the samples that I got from the samples were taken from fishermen, and we have no idea of the soak time of the traps. We have no idea of the exact mesh size that was used. So more investigation is needed on that side. And it is important to investigate that because if it is true, the shrimp could be fished before they can give their maximum yield. There could be possible growth of fishing. Finally, there could be also a big economic impact for the sector, especially for retailers and fishermen. For retailers, because probably they are paying more than what they should be because of the parasite, as we saw before. And for fishermen, because the Bopyrus squillarum impacts a lot the saleability of the shrimp. So the customers will be put off by the appearance of the shrimp that has this parasite. In conclusion, I would like to remind that this is an exploratory study, and now more steps are needed to investigate deeper the impact of this parasite on the shrimp and on the fishery. For example, to investigate more the impact on recruitment, better models could be developed, and models that predict the recruitment or the egg production for Palaemon serratus could also include the prevalence of the parasite, the prevalence of Bopyrus squillarum to also account for that effect on the egg production. About favoring retainment, to find out if the bulge favors retainment, fishery-independent methods should be used to find out if the prevalence of the parasite is in fact the actual prevalence of the parasite is in fact what we see in the samples taken from the fishermen, as the fishery could be biased towards the shrimp that are infected. And also other morphometric measurements could be taken of the shrimp to find out if there are other measurements that could influence the retainment of the shrimp in the pot. And also to investigate the actual economic impact of Bopyrus squillarum on the sector. Interviews could be carried out with customers to find out what are the choices of the of the customers about the infected shrimp, if they will buy them or not. How much the prevalence will influence their choice.